Hi, Moitri. I have joined and I'm online. Yeah. Okay. Good
Hello.
morning, everybody.
Good morning, sir. Sir, can you hear me?
Yes, I can hear you. Is
Good.
my voice good?
Yes, sir. Yes, sir. Sir, good morning and welcome to Assam Downtown University, sir.
Thank you.
Thank,
Thank you.
thank you, sir. So myself, Prashanta Buiragi, Assistant IT Officer. Okay, and Motivem is with me. So we are going to start the session exactly from 11.
Sure.
Okay. So I made you co-host so that you can share the screens and show the presentation, sir.
Thank you. Thank you.
Welcome, sir. हाँ unmute हाँ अपनी unmute कर लो हो गल अपनी unmute कर लो hello Vikas sir.
Yes.
Sir, one more information I want to give. We are make it live streaming in our editive YouTube channel, sir. This lecture sessions. It is
Perfect.
live streaming on YouTube, sir.
Absolutely good.
Uh, Thank you, sir.
Thank you. Thank you for letting me know.
Uh, Hello, Unni sir. Can you hear me, sir?
Yeah, Professor Guni, you are mute.
Yeah, yeah.
Sir, the problem is solved, sir.
So
Yeah.
nice to see you. Good morning.
Good morning, sir.
Good morning. I've seen
Good
you
morning.
somewhere.
Good morning.
Good morning, Professor Telugan.
Shrestha, I've seen you somewhere. Your face is quite familiar. I don't know from where.
Yes.
Huh?
My name is Vikas. And
That
since
I know.
Modi ji is in the power, Vikas is all seen all over.
No, not like that. I can't say to everyone that face is quite familiar to me.
No,
If
I
I'm
think
familiar,
I
that's okay.
also felt the same. Probably we met in some conference.
Maybe that is the reason. Maybe because of your hairstyle and beard is little bit different. Otherwise, maybe this sort of a style you've taken up recently because of the COVID.
You are precisely correct. In fact, I have put a hairband because I am scared of going
Yeah,
to the
that is
barber.
it. That is it. I have seen.
Otherwise, I am all over all my hair.
Maybe.
You have a great memory.
Yeah, that is what I said. That is what. The moment I have seen you, I could recollect. I'm
Yes,
old,
thank
but
you.
still I can recollect.
No, you.
Nice to be there. It's very good. You become a part of the university system. Very
No,
good.
my pleasure. Because Dr. Moitri has been always calling me. I could not be there in
Okay.
person, but I thought I should take this opportunity.
Yes, it's a good thing. It's a good thing because we have got a cross section of people, for different sector. So I was
Okay.
also thinking from somebody from an industry is also very much needed. But many of them are working with industry related projects. But a person's worked in industry for a longer period, their outlook will be very much different. And as
Yeah.
of today, it's very important you have to be an example to the government that private institutions and universities can also do better job and better research than government. Because government, they get money like anything. But what is the outcome? Because it will go as a part of their day-to-day life. But in private, it is not like that. Every rupees what you get are being monitored by the organization. So there, we have to do quite a lot. So therefore, a part of a system with a private university, private, then with the government. We have, if you see the list of people, they all are like that. Anyway, nice.
Today, Dr. N.C. Burrow sir is also joining. N.C. Talukdar sir.
Okay. Has he
Hello.
come already?
Yeah,
Hello.
Dr. N.C. Talukdar sir. Yeah. He's
Hello,
there.
Dr. Unni.
Yeah, nice to see you. I've seen it. I've seen you. Yeah,
Oh, you
good,
didn't
good,
see
good,
me.
good. Very good. Very good.
Okay, now we'll start. Okay. Good
Good to see
morning.
you. Yeah.
Good morning, all the participants. Today we are going to start the 4 days webinar lecture series. Our first speaker for the first session is Dr. Vikas Srisod. Okay, he's a senior vice president, global operation, Jubilant Campuses, Noida, Uttar Pradesh. Let me give a brief introduction of Dr. Vikas. Dr. Vikas is the vice president and head of operation of Jubilant Campuses, is a very creative, result-oriented medicinal chemist with broad experience in drug discovery operations, including medicinal, synthetic chemistry, biology, and IP management, with major contribution in the area of CNS therapeutics. During his 15 years of industrial experience with drug discovery and services in India, he has led the science, operations, IP strategies, and has mainly contributed to the growth of two startup companies, which grew to the critical mass of 250 team. At Zydus Research Center, he worked on discovery of novel modulators for nuclear receptors. During his association with Shobhan Life Sciences, a startup discovery group, he developed an integrated team for drug discovery and filled over 20 PCT applications in the area of CNS therapeutics in a short span of 4.5 years, with a candidate in clinic for the mild to moderate cognition. As head of medicinal chemistry at Oxygen Healthcare Research, a Cambridge-based startup, he developed the effective and knowledge-driven customer-centric teams. With a team of over 200 and annual growth rate of over 20% in 5 years, Oxygen Bio was acquired by Piramal Healthcare in 2011. A pharmacist by training from Pune University, he completed his master's and PhD with medicinal chemistry, specialization from LM College of Pharmacy, Gujarat University. Now, I request Dr. Vikas to start his lecture. Dr. Vikas.
Thank you, Dr. Maitri. I fondly remember the days of working together with you in Zydus, and that was in the last century, I think 99 and 2000. That was such a great time for research, and I remember you were scaling up some new molecule which finally went into the market.
Yes.
So research connects me, and this was a great opportunity. I thought I can have a dialogue started with your university so that I can have a better bond and keep coming and keep connecting to all of you.
Thank you.
We are going to talk about the pharmaceutical research and what we are doing in this country. Now, this is a topic which is not new and which has been discussed on and off many times, and what the industry can do and what should be we doing and why the things are not moving ahead, kind of stuff is always something on the go. So uh, I'm going to share in between and unshare so that we can have a good balance, so that people don't get bored of seeing my face or the slides. So we will talk about some of the research in public and the private funded organizations with respect to particularly the pharmaceutical and the healthcare research. Now, there is a lot of data which I'm not going to burden everybody with, but more of the thoughts and what we can do, what have been done in the past, and what I have been doing in the last, say, for example, 15 years, 20 years of my experience in the industry and in the academia. Pharmaceutical research is the most important thing, and when we look at India as what we are doing, we are no less, we are far ahead of the rest of the world. So what we will do today is we will look at the introduction to the subject, followed by introduction to Jubilant. Why I have chosen to introduce Jubilant is actually it gives you a complete scope and wide spread of the pharmaceutical research from point of innovation to the point where it is being served to the patient in the market. And that covers all the activities. These are all the opportunities for us. More so due to the corona and the current situation, we are more and more realizing our interdependence, and some of it is not good. The dependence on the other nations or the other parts of the globe. We need to be self-sufficient, as even our Prime Minister said, we have to be self-sufficient. Gandhiji said it 100 years ago, and we did not listen to him completely. What can we do in terms of the pharmaceutical market for bringing India to the forefront? What can we gain from it? And should we keep doing the manufacturing as we are doing, or should we move the things to something like research? Is the topic that we will talk about. What are we doing in the Indian pharmaceutical industry? Have we achieved something is one thing, and what are the outcomes so far? The key outcomes is what I will just hit with a slide. And then what are the potential growth aspirations? What are opportunities? And then we will see what it takes to drive the innovation. Are we lacking something? Are we having something? All of it, and we are just lacking in attitude or some of those softer things. And I believe finally that academia should be the guru of all the industries in all the segments, and more so when it comes to the pharmaceuticals, because of so much widespread academic network in India, highest number of student and all that kind of stuff is what we are going to look at. So basically, I will also go on and off with the slides and describe you about what Jubilant does. We are actually a vertically and horizontally integrated organization with 1.3 billion dollars of revenue in last fiscal year. But that is not the point. What we do is right from the beginning of the drug discovery, which you see on the right side of the slide, to the intermediates and generics, where we do a lot of research, green chemistry and all of other stuff, making India, independent of all the geographical locations to in these areas with vitamins and animal nutrition. But also we work in the APIs and the dosage forms, and also produce the formulations which go all across. So this is not an attempt to do the marketing for Jubilant, but an idea to give you what we actually do. We have two research centers, one in Noida, one in Bangalore, and we operate all of the things out of this. So the next slide, which I'm going to talk, is more about what is the drug discovery that we do. What is the whole gamut of drug discovery? What are the things that we can do from India, and that doesn't essentially connect to only the people who are connected to the profession of pharmacy, but also to the profession of the basic sciences, the medicinal chemistry, the physics, the quantum mechanics, the IT, the computer applications, and all of this in today's scenario is so very well connected that everybody actually can contribute to the healthcare and profession of pharmacy and the drug discovery largely in our country.
Yes.
When we start the drug discovery, how it starts basically is with the very basic concepts that actually define the whole stuff. Uh, when we try to know the mother nature, uh, for example, it starts with identifying the disease, what it is, what is wrong in the body, which needs to be corrected, what can be done in terms of the enzyme regulation, or can we attack it with a receptor modulation, or any other strategy that we take to cure a disease, a particular disease. Therefore, the things actually start with a structural biology, which actually sees these malfunctioning proteins or DNAs or enzymes in the body in the three-dimensional structures with the help of good computer applications, where in which we need the intelligence of physicist and a chemist and a biologist all put together. When we study the structures and we come across some of the binding possibilities on these molecules, then the small molecule approach comes into the picture, and then the chemists of the world try to modulate these supramolecules which are in the nature. Supramolecules meaning they are the compounds which are more than 10,000 daltons in the size, huge protein molecules, or the receptors or the enzymes that we want to modulate, and we want to see how we can key this lock and change the conformations of these large proteins in a very small manner, tweak them so that we can cure the diseases in direct or indirect manner, so as to cure the ailments. All the all the all the solutions and drugs which are available today on the market use ultimately the same methodologies fundamentally. Now, this is where the chemist also comes into the picture, and the opportunities are all visible to all of us. So, starting with the physics, the computer application, the chemist, and then the medicinal chemistry kicks in, wherein which we try to find out the small molecules who actually bind to the larger molecules and give the solution to us. When you synthesize these small molecules, you need the platoon of chemists, hundreds of chemists. That's what we need. And deviating from the topic, I must say today is a great day in my life at Jubilant, because 7 years ago when I joined here in Noida, we had a team of about 200 people, which we are now 500 plus. And today I'm at our new site where we are inaugurating the opening of another 500-man facility. So this also is an appeal to all of you gurus of the profession who are associated with the pharmaceutical research in direct or indirect manner, or chemistry, to direct your students to come to us. And those who have passion in research, they can work with us in Greater Noida. This is a beautiful facility. I will show you the picture as we go along. So the medicinal chemist, when he comes into the picture, actually he designs a lot of small molecules, and you need a platoon of uh, army of chemists to make this thing possible. Now, these are the small molecules which are never ever prepared ever by mankind in the past, because you have to be novel. That is something, the basic necessity, if you want to do research and you want to have these patentable innovations or inventions, so to say. So with the help of computational chemists and the medicinal chemists, these chemists make hundreds of molecules, which are then screened by the biologists, who are again a cross-functional team. It is not a biology, not a chemistry, nor is it a physics, but those who have worked in the industry and the interface of biology and drug discovery, who will understand what I mean. Dr. Maitri has been associated with drug discovery for a long time. So how much is interfunctional these teams are, and these people see whether these small and the large molecules are interacting efficiently. Do they talk to each other and make the right effect? Going from there, which happens in vitro, is the story which starts for the in vivo and the animal models. And then we do DMPK, that means drug metabolism and pharmacokinetics. Thereby, what we study is the effect of drug on the body and the effect of body on the drug. So the way in which the body actually transforms these small molecules and throws them out of the body like a toxin, and the way in which these small molecules make an impact on the body, on the homeostasis of the physiology, make some finer tweaks into the enzyme and the receptor systems of the body, and make the ultimate effect of the drug into the disease condition to make the positive impact. Now, what happens is, it could be so simplest of the example is, say, for example, diabetes, where you want to modulate either the insulin secretion or you want to modulate the metabolism of the sugar. That's how the things work here. When we have done the effect of body on drug and the drug on the body, the next phase is to test this hypothesis on the animal kingdom, then the mammalians, the small mammalians, and the larger mammals, and then take this to the next phase. So this whole phase of discovery is what is innovation phase that we are talking about. So it involves target ideation, target validation, and when I say target, it actually is those supramolecules, the large molecules that we are talking about today. Those are the enzymes, those are the receptors, those are the targets for the drug discovery. Lead identification, hit identification means these small molecules which we actually utilize to make them into the drug molecules. So this is the very complex phase of drug discovery, which where it starts, and then it goes. I'm sorry. Then it goes into the larger scale manufacturing, where in which the earlier small scale synthesis, which happens only in few milligrams, which you can barely see with the naked eye, goes into the large scale manufacturing. We make few grams of it, few kilograms of it, and then the processes are said, the engineers of the process comes into the picture, and the large scale manufacturing starts in, and then the formulation is developed, which is tested on the animals. Going from forward, when the clinical trials phase 1 and phase 2, meaning the safety and the efficacy of the small molecules is established, then it is also taken for the next phase to the, I'm sorry about this, taken to the next phase for trials into the patients. When it is useful in patients, that is the time you apply to the drug regulatory authorities of various countries, manage your patents, which is a very expensive business, taking from preclinical animal safety that you see at the bottom in the orange to phase 1, phase 2, and phase 3 clinical trials, filing of the global regulatory authorities, and then the product is in the market. Now, this is not a very simple activity. It needs all the sciences all put together. It is not one science. Pharmaceuticals needs engineers, it needs physicists, it needs computer engineers, and also the chemists and the pharmacists. What are our opportunities in this area? For example, if I look at things what have happened, what has India done, and I must say that we talk good and bad about our Indian community. For example, are we doing good? Do we do research? We are not doing anything. We simply talk. There is no industry and academia collaboration. This is the biggest topic we have been talking, and I'm listening for last 25 years since I was a student. Is it true? How true is it? Do we do enough, or what is more that we need to do is the point of discussion here. Now, if we see some of the statistics here, what have we achieved in the positive light? India, we have a very low per person disease burden, that is up at the 36%. You look at managing the epidemics, managing the communicable diseases, forget about the corona situation today, which we are actually managing very well. We have eradicated polio at 100%. This is one of the biggest achievements for this country. We are also going ahead with other communicable diseases like tuberculosis and other stuff. We, as an industry and academia so far, have achieved a 95% lower treatment costs in this country. And this is not only coming from industry. I would say it is often said and put in the light that industry is contributing and academia is not helping. But in my opinion, it is actually the academia which is feeding into the great manpower, the innovative brains, and the intelligent minds into the industry who are making it possible ultimately. It is a machinery which is working together. We cannot separate them out. What we have done is huge number of manpower which is employed. A lot of manpower and employment is generated. We have annual trade surplus of 11 billion only for the pharmaceuticals. So pharmaceuticals industry is one of the top 5 contributors to the GDP and the foreign exchange that we generate as a nation. In addition to that, $2 billion worth of FDI inflows have been seen in the last 3 years, meaning that people believe in the abilities of Indians for manufacturing, for research, and for all of them. Where are we lacking then? If the whole of the rest of the world believes in us, is it that probably we are not looking at it in a right light? Where are we lacking? Why? What is the reason why we do not have most of our drugs coming into the market originating from our own country? Why are we getting the compounds and the drugs from Europe and US innovations and paying the royalties to these developed countries for even the smallest of the ailments, barring those which are off patent like paracetamol and other stuff? But look at the forefront of the treatment and the healthcare system today. We are paying royalties, huge amounts of royalties. Even even when we say that the treatment costs in India are low, we have almost what we have people coming to India for medical travel. For example, tourism, they call it a medical tourism industry, which itself is a big one, because we are inexpensive in terms of treatment. You would be surprised, and you must be knowing all that even from the people from the developed countries come here to get treated. They have belief in our talent, they have belief in our medical professionals, they have belief in our support services, they have belief in our healthcare system, and therefore they put their own lives to the test and get treated in this country. What is then lacking? Well, only small area. What India has not hit so far in the 50 years of the history of pharmaceuticals in this country is the innovation area. Why there are so less research centers in this country? Most of them being controlled and driven by pharmaceutical industry, which of course has commercial interest. And why not? Why is there a lack of lot of research initiatives from the academia? Why are we lacking there? That is a question that we need to ask ourselves. What I see, also I have to show a couple of slides and snippets, like what is about Indian farmers, what are the growth aspirations. If you see today, 2018 data is the best data I could get, which is sourced from IQVIA and Pharmaxil, which is a validated data. $38 billion was the market potential in 2018 of Indian pharmaceutical industry. Today it is about 42 to 45 billion dollars. But that's not important. At the base rate, if we grew at a normal rate of 7 to 8%, by 2030 we will be 80 to 90 billion dollar industry, which means we would have grown 3 times. I mean, look at this beautiful thing. Our own investment, if they grow 3 times in 10 years, we are the most happy people. At the base rate, at the minimal rate of 7 to 8%, also we have 3 times growth. But if we take extra efforts, it can go to 4 times or 5 times, 120 to 130 billion dollar industry in next 10 years. What it means is we need to be completely prepared to attack this, to take this opportunity, and opportunities are flying our way. Look at this situation of Corona today, and I should not be talking this from the official point of view, but simple things that the manufacturing hubs like China are in strategic dilemma as on today. And this is an opportunity for the rest of the Asian countries to grab. If I ask an open question, which is the biggest Asian country who has ability to take this opportunity, only India is the answer to this. And this is where we should be focusing, not only on manufacturing and getting the things right, but also on the innovation, which I am slowly coming to the topic of innovation. So if we want to emerge as a pharmaceutical innovation leader in this world in the next 5 to 10 years, we have to continue to do what we are doing and actually double it, triple it at a very high rate. Innovation, they say, is
Yes.
very simple phenomenon if it is embedded in a culture, but not so simple when it comes to make it a industrious effort to get into the market. We have to focus on the discovery strategies. We have to look at the funding strategy. We have to focus on the grassroots innovation.
I'll come
We have to
around
look
1
at the
o'clock
role
only.
of
1 o'clock.
academia,
No, why?
and we have to also see the role of
She
industry
cannot give this way.
that we are supposed to do. Okay, so looking at these things,
Okay.
I'm just
I'll
trying
ask
to
her.
bring you down in next 10 to 15 minutes to what we can do as a strong academic team, which is the best in the world, I believe, which is the strongest in the world. Uh, Looking at the larger picture, what government wants to do, including creating a stable and supportive regulatory environment, creating the SEZs, exploring the creation of independent Ministry of Pharmaceuticals, which has been done already,
Any consent
facilitating the API production,
bold
promoting the
paper,
innovation by
sign
creating research
scan
ecosystem. This is where I should focus more for the topic of the day.
scan
What is government doing? I mean, I see that this is also, this webinar is being conducted by the innovation cell of your university, which is at the forefront. But what we have to see is, are we participating in the process of innovation wholeheartedly? Are we ready to do expression of all the ideas that we do? If not all the ideas, are we able to even having the filtration mechanism to choose and pick the best of them, highlight them, and then take the help of everything, every resource allowed, and express it in a manner in which it can become a big success? Looking at the stories of the phenomenal successes of all the biotech innovations, every story has started like this. We have to expand and upskill the talent pool to handle the complex technologies. So when you are talking about upskilling, when you are adding talent to the industry, again it comes to the grassroots level of academia, and that's where the gurus and I'm very happy to see that some really senior teachers are on this call today, who have contributed and generated so many students and gifted them to the industry. But what are we doing right there, which happens to be the source of all this innovation, which happens to the source of wisdom, which happens to the source of ideas, which is a place where hundreds of thousands of innovative young minds come up and join the societal revolution, I would say, to contribute to the next generation. Are we making use of these people, their 3 to 5 years or 8 years, if they do PhD? Are we using these minds there itself, and are we instilling those ideas into their minds? In academia, it's a small focus, teachers, and I would finish this talk in next 10 minutes and focus on more of a questions and debates, because I see Professor Gunni, Professor Talukdar, and other senior faculties on this call. So to generate discussion and debate, that is my passion. But if we look at industry and innovation ecosystem in our country, the, the funding ecosystem is coming up. There is government who's funding in larger way the proof of concept kind of innovations. It may come from students, it may come from young innovators, and they are helped at every stage. If you see today, there are not only private incubators in the in multiple universities, but also the government funded incubators like Atal incubation centers that we see all across the country, and I'm sure you are aware of them. Some of the universities are fully funded with these initiatives, where in which the universities use their own infrastructure to start the idea, to make the first proof of concept kind of things. But when we come to the academia, we also need to think back and really analyze what we are doing with this pool of thousands of intelligent, innovative young minds that we have at our disposal. What are we giving them? Are we giving them the old curriculum which is going on and on for years together? Are we looking at revamping it? Do we have to wait for change of curriculum to instill some good qualities uh, into the students? Do we need to consider adding new aspects to teach? I mean, it's a very controversial word. Teaching in the university is a different phenomena where in which the teacher learns and the learner teaches as well. The job of a teacher, all of you know, is to only instigate these young minds to come up with something beautiful and new, and that is the outcome desired. But are we looking at this? If we look at the current way of post graduation and even the PhD courses that we are running, we have enormous talent available, and I'm repeating it again and again. Hundreds and thousands of young minds. Are we motivating them to the level that we need to? Are we instilling the independent thinking philosophies into them, and the attitudes of thinking out of the box? And there are many. As I work with a lot of youngsters and young minds from the academia joining our research centers year after year, hundreds of them, and that's a very small size. I am really constantly influenced by them and impressed by them, because they come into our industry which is running for years, and they come and tell us, why are you doing it this particular way? Can you not do it differently? This is the easier way. And then, wow, I said, wow, this is the innovation, and we keep improving. But the matter is, are we open to listen? Look at the facilities like Atal incubation centers that we are doing, the business and the now knowledge and the whole coaching of the younger minds. Are we getting into the philosophy? I remember 15 years ago, Dr. Mashilkar gave us a mantra: stop publishing and go patenting. Okay, that was not taken in all the good manner, but there are a lot of patents since then, and the patent scenario, landscaping, and the attitudes have changed in our country. We are patenting many innovations from the industry. Even as we speak of the corona right now, I see a lot of innovations coming from academia, industry, academia, and all of that, which we need to gear up to the next level. Prototyping. Can we make prototyping of innovations as a part of the curriculum, even in the graduation or in the post graduation curriculum? Just give them some basic tools and let them do what they want to do, the students, and I'm sure they will actually transform with the help of hand holding from the teachers and the gurus of the different profession, and they will transform this country into totally new Sone ki Chidiya again. And I always believe that academia can be the idea hub, who can actually generate ideas, think through, and bring in a lot of new concepts and drive the industry. Now that is the ecosystem which exists largely in the West, and then the professors are bigger than the CEOs of the small companies, and that is what is possible even in our country. What we need for research, multiple things. Okay, let us see what we do not have. That is one thing, because I've been hearing, when I talk to the people, when I talk to the academics and the industry people and the students, young students also, I hear a lot of things. Oh, there is no funding. Nobody's ready to give some smaller stuff. People don't even give sample. Why do you want to depend on it? Just go into the market and get it. I believe if there is an attitude of innovation, you can do it. Uh, we need to develop it. We need to instill it. We need to create that attitude into the students and into ourselves. We have to create the entrepreneurial mindset. I do not mean thereby creating a lot of MBAs, but But this mindset of entrepreneurship should be a part of our curriculums, which actually is the leading necessity for innovations to grow in this country. We can teach it. I have learned everything from my teachers, and as I remember, even when I was graduating, no, there were teachers who all of us were motivated by and taught by them to think out of the box, to go do it, just get it done. And that is the mantra that we should always remember. Nobody is born businessman, but if we can tweak them, if we can give them some wisdom, which is in ample in the teaching fraternity all across, it is possible. Business acumen is nothing more than a elevated or a refined form of common sense, I would say. Right, just get it done and make the benefits to the masses. It is possible. Infrastructure is one of the most important things. I also hear that it is not possible. We do not have we have labs which are not good, but nothing is stopping us. We can make our labs better. The institutional infrastructure as on today is good enough to start something, and then who stops us to collaborate? Uh, a chemistry college doesn't have biology facilities. So biology college doesn't have chemistry facilities. If you join hands together, you are like a small industry and do a lot of innovation. And if you do the innovation, the whole industry will run after us, run after the academia. They will come hungry, walking, running after us, ask for, please give us, let us know what you are doing. We want to make it commercial. And I believe it is possible. Infrastructure is not there for a limitation. It is the first thing on this slide. That is the innovation attitude, which probably is our blocking stone. Diverse talent is one more thing that you need to do the innovative research. The whole world knows we have the most diverse talent in this country. We have highest number of young minds, which are the most fertile, creative minds available on the face of earth, concentrated in this subcontinent of India. Are we using them? There is no lack of ideas. It is the lack of expression. Are we motivating them? Are we giving them enough confidence to go ahead and express your idea? He may fail. We may fail. Stand by them. Let them fail. And then they will succeed. Now, what we want by that is only decision to each and everybody in this nation, in the profession of education, that do we want to do it? And that's all it needs. Once we decide, we will do it with a great tradition of this country of innovation in all the sciences, right from astrology to the healthcare, from Charaka to Arthashastri like Chanakya, to the surgeon, and to the with a great history of Ayurveda. We are we are blessed as Indians. We have a lot of innovation in our DNA, and only thing is we need to come out, bring it out, let it come out, not inhibit it. And the best can be done with the help of these young minds. That's what it is. I believe that we can do it, and this is what should be the focus and attention going forward. Is what I believe. If the help is needed as an industry support, from personally from my side, I have been associated with multiple academia on multiple fronts, training, motivating, guiding the research, and all of these things. Enough talent and guidance is available, regulatory guidance is available in the society, and we should be able to use it, is what I strongly believes. And with this, I want to show you, I'm seeing Piyush has raised hand, but I will come back to you just in 1 minute. I'm just trying to show you the picture on one of my slides, that we have. This is where we are shifting. This is the place where I'm sitting today. This is the dream for my whole team of 500 scientists, which is coming true. We are expanding with another 500 people today. And immediately after this call, because I was committed, I could not say cancel this discussion today. Uh, we are doing a puja and inauguration of this facility for building for another 500 scientific minds, wherein which I look forward to see the people whom you have touched, the students whom you have all taught, and I would be very happy to welcome these students into our facility going forward. So Piyush is the person who raised the hand, and I would be happy to listen to you, Piyush. Okay, so I think Piyush is not there around, but I see some of the questions which are raised by some of the participants. I am reading is Dr. Madhulika Datta, who's saying which one is the most effective among supramolecules and nanoparticles for using as a drug to reduce the metal toxicity in the body. Also, which one is more eco-friendly? So supramolecules and the nanoparticles as reducing metal toxicity have their totally different mechanisms maybe. Probably I do not have more depth into this area, Dr. Madhulika. I would be happy to connect to you later. But what supramolecules do is probably they kind of chelate, they form the coordinate complexes with the metals in the body, and thereby they are cleared by the body system outside, thereby reducing the burden of the metals in the body and reducing the toxicity. Whereas nanoparticles, probably you are talking about the self-assembling nanoparticles, which will also agglomerate around the small metal particles and clear them. I do not see a great difference because of my lack of detailed knowledge in this area. But I think if they are organic compounds, supramolecules or nanoparticles, if they are made of the organic stuff and they are degradable, I think both could be eco-friendly, unless there is something which cannot be consumed by the nature and degraded to the base elements. Dr. Madhulika, moderator, can I have the have everybody unmuted so that I can hear them? Professor Sankar, uh, Professor Sankaram Padi, you have raised also some question here. You say that the lifestyle of the present days seem to call into being wide variations in the diseases. This has resulted into the trends of personalized medicine and translation research. Yes, and what is the most recent in these trends? And small molecule targets of the drug design, high throughput methods like combinatorial chemistry were required along with the QSARs and the CAT techniques. Yes, Matri? I'm, 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 I'm not. Oh, okay, okay. I see the movements, Professor Talukdar. Are you able to hear me? Okay, I will rather continue talking. I was reading. Okay, Madhulika says looks like we were not connected. So there are some people which are not connected. I am just checking randomly. Professor Swaroop, are you hearing me? Okay. Then Dr. Barua, Dr. Sarma Barua, are you hearing us? Okay. Dr. Sankaram Padi, are you hearing us? Okay, sir, I was reading the question that you have posted here. And yes, I completely agree with you. The changes in the lifestyle are really big challenges today. They are actually not only modifying the existing disease, but also generating the new diseases. We are going more and more personalized. Therefore, currently, whenever you look at the new therapy which is being designed, the question is how many patients are going to be treated with it, because there are more and more smaller population diseases coming up. Yes, therefore the personal medicine is a recent trend. It also means that more personalized pharmaceutical professionals are required to treat. What we have been doing traditionally is we say, okay, paracetamol, and everybody's fever is gone. I mean, I'm just giving a gross example. But today what we see is we have an ability to see with the AI and the intelligence of the artificial intelligence and the IT tools, is what is the history of a patient, what has been he going through, what are the problems that he has seen in the past, what are the reasons of his symptoms versus the other people's symptoms. And not everybody, everything is not same. We are all different, and therefore it can be customized for the treatment, and therefore more attention to the personalized medicines. Yes, the computational combinatorial chemistry, as you say, sir, is required to produce large number of small molecules. Also, the high throughput screening, which we do on and off every day in our facilities, to generate and to conceptualize and find out what is going to work. So that's very true, and I'm all with you on these thoughts. And thank you for sharing these thoughts, Professor Shankar Padi, on this forum. I think everybody is back. I think there was somebody
Hello,
called
sir.
Piyush
Hello,
who
sir.
raised the hand.
Hello, Vikas, sir. Prashanta here.
Yes, Prashanta. There was
Sir, sorry,
Mr.
actually, the weather is very bad, sir, here. And electricity gone. So that's why some inconvenience are there, sir. And sorry for the
No,
inconvenience.
Prashanta, there is no problem. No problem. We are continuing. And some of the
Yes, sir.
participants were still online. So we were continuing.
Actually, sir, here from our side, it is disconnected, but the meeting is going on.
Right. I think there was Madhulika, whom I answered. Also, there was one question. Dr. Gunni has suggested people to place the questions, which I see a lot of them. I hope Madhulika is back and she can connect to me later on. Then there is Pranjit Kumar, who says how the thermodynamical factors affect the mode of drug action. Of course, there are details. In fact, thermodynamic models are some of the first things that we take into consideration when it comes to drug discovery, even when at the concept level. And we subject these mathematical models of molecules to thermodynamic computational chemistry stuff, energy minimize them to get to the right conformation, to check what is the right thing to do. It has an impact. Yes, Pranjit, they do affect. Even when the drugs are in the body, the thermodynamics plays a great role, because the temperature, pH, and the surrounding variations cause the changes in the conformations of these small molecules. And these molecules are only effective in particular conformations. At the higher energy, for example, molecules assume wide open conformations, which they become not useful. And therefore, yes, thermodynamics plays a very critical role in the way the drugs act on our body as well, and also the way the body acts on the drugs. Srinivas, yes, Professor Talukdar, yes. You're on mute. Professor, you are on mute. You have to unmute. Prashanto, can you please unmute Professor Talukdar? Okay, I could not hear that. So Dr. Moitri, I would request you to modulate any questions if they are, because we have 5 more minutes before we can close this. I must thank you all for patiently hearing to me, and I would be very happy to again connect to all of you at any given opportunity in future. I think admin has to unmute the participants, is what I'm hearing. Thank you, Swarup.
Can you hear me now?
Yes, I can hear you.
Okay. It's a question. See, you get a lot of employees from trained in university. Now there is a question of innovation, and then most of the students or PhD holder in most of the universities, they're not exposed to the way they should be to industry environment. Now, my question is, what kind of difficulty initially you face with, means what I'm trying to understand is, can you have some reflection on what is going on in the academic institution while we train students that they are not really made to be immediately taking up a job in industry, kind of that innovation skill or their inclination towards industrial, uh, like towards what they require to work in industry. If you talk,
Fantastic.
yeah, like,
Thank you, Professor Talukdar. This is a great thing. I would be able to close this session with answering your question, and that was so appropriate. To be very frank, we do get very fresh students, and Professor Maitri, Dr. Maitri, I can see the smile on her face also, who has worked in industry for a long time. We need about 6 months, sir, to train these minds to think in a particular way, to get into the innovation. We have to really motivate them to express their ideas. And as I was stressing all through my talk, this is only the training of expression and the softer skills that needs to be motivated in these minds. They do have everything here. They have everything. You have trained them well. But when it comes to industry, we have to spend 6 months about to train them. Some of that is on instruments and safety aspects, which is absolutely necessary. But I believe if some of that part is done in academia itself, say for example the Masters of Sciences, in last semester, if there are about 2 months spent on training industry specific syllabus or the skills, it would be a great help not only to the academia but also to the students and also to the industry, so that they can come into industry and quickly get accustomed to what they are supposed to do. And therefore the whole nation will actually help. This is a big help. We are right now trying to collaborate with many universities, wherein which we will be the part of your last semester, contribute to teaching and training them, so that they can be, we want to select them, we want to take them to our research center, and then use this intelligence to serve the whole globe. We have collaborations right from Japan to West Coast, and once they are here, they get a lot of opportunity to interact with the global scientific community and develop themselves. This is exactly what we want to do. So, Professor Talukdar, I hope I answered your question. There is
yeah,
not.
I think you have rightly said so. Like when we talk about academia and industrial collaboration, now see these institutions, a university has different departments. If you talk about pharmaceutical science, now different departments during the training of the students at the master or PhD level, there has to be coursework, there has to be intense collaboration, interdepartmental collaboration in the university itself, right? So which we are lacking. Many a time there is innovative, the innovation, it will come only when you work not in your own field, you get to know what other people are doing. For example, a chemist, if you see what a botanist does and how they're very intimately linked, the chemist getting a molecule from a plant. Now, once he goes to the botanist, like I think we don't have time. I just wanted to, yesterday, I had a very peculiar experience. One student has been doing work on a particular plant, extracting, fractionated, got the molecule. Now, when I asked her, that, okay, it is a useful molecule. Where are you going to get this molecule in large quantity if it comes as a product someday, because you have
Yeah.
got it from the wilderness? Now,
Yes.
that thinking process, now then I grew some plant or that plant in few pots. So I've been telling them that go on observing what happens to them. Then she said that because her work is in extraction and purification of compound, isolation of material, she's not interested in that. So when you
Absolutely.
talk about innovation, there has to be inbuilt in the in our academic program that this marriage between interdepartmental activities and students that happens, right?
Absolutely, sir. It is interdepartmental. And in fact, innovation happens only when there is an interplay of different minds, of
Yes.
absolutely unconnected sciences. Science is one thing, I believe. There is nothing like walled chemistry and biology.
Yeah.
Everything is one. And that inquisitiveness only gives birth to great innovations. And I believe we have it all in our people.
And our
And
course curricula, like we have to rethink on devising our course curricula in the university institutions. I think
absolutely.
we have to do it, right?
Thank you, sir. I
Thank
think
you.
I had requested Dr. Maitri to let me go 5 minutes before, because there are senior people waiting for me for this puja that we are going to do.
Okay.
Uh,
Okay. Thank you very much. It was nice seeing you and interacting because
Thank you, sir. Thank you very much. Thank you, everybody who joined. There are about 80 participants, I think, and I'm very happy to be of some help and use to this whole community today. Hi, Dr. Moitri. Yes. No problem. No problem. No problem. I will close it from my side. I will close it from my side. Okay. Thank you. Thank you. Thank you. Thank you. Thank you. Yeah. Hi, everybody. I think the moderator of the session, Professor Dr. Maitri, is not connected. So thank you so much for your presence, and we will close the session here. Oh, she's there. Okay. Thank you. Bye.
Thank you very much. Then our next session will start at 12:15.
Live. Hello, Saurabh sir. Can you hear me, sir?
Can you hear me?
Yes, sir. Yes, sir.
Okay, fine. So earlier session also I wanted to say something but I could not unmute myself.
Yes, sir. Actually, the problem is that there is some technical issue here. The weather is very bad, and due to the current electricity, everything is shut down. That's why
That's
the
okay.
co-host or host some confusion are there. Now it's okay, sir.
মই স্ক্ৰীনখন শ্বেয়াৰ কৰি চাইছো আহিছে নে নাই চাবা তুমি আহিছে নে ভালকে
Correct second. আহিছে sir.
ক্লিয়াৰ ন
আহিছে sir. আপোনাৰ
ঠিক আছে।
স্ক্ৰীনখন দেখিছো ডেস্কটপ হেৰি
ঠিকে আছে মই ষ্টপ কৰি দিছো এতিয়া নেক্সটটো 12:15 আৰম্ভ হ'ব নে থাকক স্ক্ৰীনত এখন স্ক্ৰীনত থাকক নে এখন বন্ধ কৰি দিওঁ
থাকিব পাৰিব একো নাই
থাকিব দিয়া 12:15 আৰু 15 মিনিট আছে
হয় sir. এইখনে মই হেৰিৰ পৰা আহিছো মেম আপুনি কাৰোবাক মেছেজ দি দিয়কচোন মই মোবাইলৰ পৰা কৰি আছো কাৰোবাক স্ক্ৰীনশ্বট ল'বলৈ দিয়কচোন মই ল'ম বাৰু মোবাইলৰ পৰা
তই কি লেকচাৰ শুনিবলৈ আহিছ নেকি? নাই মই তোক লগ ইন হৈ থকা দেখিছো, সেইকাৰণে মই বোলো কোন কোন আছে। বাকী ভাল খবৰ? হেৰি কি মই কিবা এটা সুধিম, গৌতমৰ ল'ৰাৰ ৰিজাল্ট কি? মই সুধিম বুলি মই ৰাতিপুৱা পাহৰি থাকিলো। মই ৰাতিপুৱা 7টা মানতে পালো ৰিজাল্ট, তাৰপিছতে মই ফোন কৰিম বুলি পাহৰি থাকিলো। ঠিক আছে দে, তই মিটিং কৰ। হ'ব আৰু দে, বাই।
then okay, very good afternoon to all the participants again for the second session of the fourth day. Am I audible?
Yes.
Okay. Today, our speaker is Dr. Swarup Nandan Bora, and his topic will be mathematical research, its direct and indirect impact on society. Let me give a brief introduction of Dr. Swarup. He is the Professor, Department of Mathematics, IIT Guwahati, Assam. He did his PhD from Department of Engineering, Mathematics, Technical University of Nova Scotia, Halifax, Canada in 1998. He did his MSc from University of Delhi, India, 1991, BSc from Cotton College. Then his present designation is Professor, Department of Mathematics, IIT Guwahati. His research areas are fluid dynamics, ocean of offshore engineering, differential equations, spatial functions, integral transforms. He has total 58 publications, and he has produced 7 PhD products, and currently 7 PhD scholars are working with him. Then he is the Dean of Student Affairs of IIT Guwahati, Head of the Department of Mathematics. He is the Chairman of Library Advisory Committee IIT Guwahati, and he has the list of achievements, a long list of achievements. And now I request Dr. Swarup Nandan Bora to start his lecture. Swarup.
Okay, thank you, Maitri. Good afternoon, everybody. I hope I am audible to all, but it's difficult to know because I think all the participants are muted. Anyway, so how do I know whether others are, you can hear, Maitri?
No. Yeah, they can hear, but they cannot speak actually. No?
Okay, sure. Yeah, so good afternoon to all. So now on the invitation of Maitri, so this lecture I'm going to deliver today. So basically what I find difficulty in many aspects, in the sense is heterogeneous. For us mathematicians, we always need something which is homogeneous. That means I think there are many participants here whose background is not mathematics in the sense that they may be specializing in some other subjects, and most of them are probably faculty members in various other subjects. That is first issue. Second issue is I heard most of the talk by Dr. Vikas, my previous speaker, and he actually delivered a wonderful lecture. So I feel my situation is something like number 8 batsman. I think for this program, I am the number 8 speaker. So I find myself as the number 8 batsman when all the other batsmen have scored very heavily. So now actually it is a pressure on me to perform. So whether I can score a century, or because all others have scored so nicely for the team, I may decide not to score at all. Okay. I'm actually cricket buff. So today is a historical day in Indian cricket. If for those people who follow cricket, so 37 years back, a result in Indian cricket for today actually has changed the scenario of Indian cricket. That is the first World Cup win for India under the leadership of Kapil Dev. So interestingly enough, I am not dedicating this lecture to anyone else, but I am dedicating my lecture to Kapil Dev and his team of Devils of 1983. Okay, so now first of all, I will be emphasizing it again and again. So what is a society? Okay, so what is a society? It is up to us to define. So society may be my IIT campus, it may be my neighboring village, it may be whole of North Guwahati, it can be the whole of Kamrup district, it can be Assam, it can be India, or it can be our whole planet. So I think for mathematicians, we don't have any barrier. And most of the time when we talk about society, we take it in a broad sense. So what I mean to say is that the works that the mathematicians have done, we cannot claim that it is going to immediately help our neighboring society. But as a whole, we have to see actually what is the contribution of the mathematics, of the subject mathematics, and also the mathematicians through the research. And everyone will agree, probably mathematics was one of the subjects which flourished long time back. We talk about, you talk about India, you talk about most of the countries in Europe. Mathematics flourished in the 16th and 17th century. And those results, actually, we can say that it was actually outcome of some rigorous research carried out by those mathematicians. So it will be very difficult to term many people as mathematicians, because nowadays only we are very narrow. I say I am in mathematics, I do not know any other subject, but most of the other people who had carried out research centuries back, they were at the same time a batsman, a bowler, a fielder, and a wicket keeper. They carried out research in maths, physics, astronomy, and whatnot. They did not differentiate any subject. But as of now, we have become very narrow-minded in the sense of studying or doing mathematics. If I'm doing mathematics, I do not know biology. If someone knows biology, he may not know chemistry. I think chemistry is needed. He may not know physics, and so on. So I'll try to emphasize certain aspects, because I think it is not a right forum for me to discuss my own research. So what I have collected, I'll just try to advocate for mathematics, being a mathematics lover, because mathematician is a very big word. I do not consider myself to be a mathematician. I consider myself to be a person who is in love with mathematics and who does mathematics. So I think it is true for most of the people. So as you can see, the title of my topic is mathematical research, its direct and indirect impact on society. And rather than the topic, I think you are fascinated probably by the picture that is on my title page, where you can see a number of windmills, okay? And if you can look at the water body, definitely it is not a river, it is not a lake, it is an ocean, okay? Now, as I mentioned earlier, slides are not going down. Let me see how slides are not moving. Huh?
Hello, sir.
Slides are not moving.
Your slide, it is on the first slide, sir.
I know, I'm trying to move, but it's not moving. That's what I'm saying. What does it mean? It's the first slide, no?
Yes, sir.
It's getting stuck or what? Oh, it's coming now.
Yes, sir. Yes, sir. Now it's working. No, sir.
Okay, as I mentioned earlier, mathematics research took place long time back, since long time back, and it will be pertinent for us to actually start with some quotes of some famous mathematicians. So I'm starting with a statement by Fourier. So even if some people are not well versed in mathematics, so they must have learned or heard the name of Fourier, who has significantly contributed in all areas of mathematics, along with other sciences like physics, electronics, etc. Then, of course, Sir Isaac Newton. We do not want to debate whether he was a mathematician or he was a physicist. But he said, my powers are ordinary, only my application brings me success. And it is basically about his observation also to see, like jokingly people talk about, if Isaac Newton had decided to eat the apple instead of studying why the apple fell from the tree, then probably we would have been left with no study on gravity. Then there is a famous mathematician Gauss. He has also contributed immensely, and he also says actually about the charms of sublime science. Then those who are in physics and mechanical engineering or civil engineering, they must have heard the name of Daniel Bernoulli. So he actually has connected with the works with nature, he always says that nature always tends to act in the simplest way. Then another top mathematician is Laplace, and actually my work has a lot of significance of what Laplace had found. So what he says is, and which I actually agree to, is that what we know is not much, what we do not know is enormous. So that will be evident from any lecture when we attend. So we'll find that we only can understand or we can digest probably half or less than that of the lecture. Then another great mathematician was Euler. And if you see most of the earlier mathematicians, they're always connecting the universe or nature to their statements. Then J.H. Hardy is a household name in India, mainly because we know that he mentored Ramanujan. And actually what he says is that a mathematician is like a painter or poet, is a maker of patterns. And he says that patterns are more significant and stable because they are always made with ideas. And I end the quotes with the quote by another great mathematician, Cauchy. He says that men pass away, but their deeds abide. What that means is that what we achieve in our life, whether it is academically or otherwise, we know that we are not immortal, but we should try to see that what we have done has contributed to society. I'm saying society in quote. For me, my society is the people who do mathematics, the people who are doing research in mathematics, and especially those people who are working in the area that I have been working. So I have too many slides. I may not show all the slides, but we know that mathematics is an academic discipline. And actually, when we talk about mathematics, we say that it is nothing but concept of quantity, structure, space, or change. Okay. So, but mathematics is always something that after doing it, we always draw a conclusion. Now, mathematicians find concepts and patterns in things like numbers, space, computers, and elsewhere. And it is not necessary that whatever concept we have is equally applicable in most of the areas. Okay. So mathematicians utilize those concepts and they want to formulate new conjectures. Then those will be proved. Then we can actually use those as results. So we know that mathematics is also connected to philosophy. Philosophy is connected to logic. Logic means we always conclude with some logical reasoning why we have actually arrived at some result. As I said earlier also, the basic mathematics ideas, or I can say when we say ideas, we can say in broad sense that it is also research. It was done centuries back in India, China, Greece, Egypt, Mesopotamia, and some other regions. Okay. We know that Greek mathematics actually first dealt with many arguments which are rigorous in nature, and we can actually cite the work of Euclid, which is stated very rigorously in his creation called Elements. Then development has been taking place for a long time till Renaissance period. Then after that, we say that it is the birth of modern mathematics. Okay, so then actually people started applying mathematics in various other areas, and actually mathematics became so important that it was very rare that any scientific discovery would have been achieved without the help of mathematics. So this interaction actually led to a very healthy environment, and it actually led to very speedy acceleration in research, and also it resulted in a lot of new developments. Now, many years have passed, mathematics has been developing, and we say that it is okay for us to say that it also acts as a bridge between nature and science, and it is a foundation on which the engineering sciences stand. So when we talk about mathematics, there are certain mathematics which is basic mathematics or fundamental mathematics actually, for which many mathematical theorems have been evolving and have been established, and we use them as tools to actually work with our own problems. Now, there are problems in abstract mathematics, there are problems in applied mathematics, though it is very difficult for us to actually differentiate what is a pure mathematics and applied mathematics. I do not agree to actually the term, though I may be using somewhere. I think everything that is done in mathematics has some application or other, somewhere or other, or sometime or at some future time. So we can say that mathematics is extensively used in natural science, engineering, medicine, economics, psychology, and many other subjects in humanities. When we are growing, we always thought that if someone wants to do mathematics, he doesn't need to know the knowledge of biology. Someone wants to pursue his degree in medicine, or he wants to pursue a degree in biology, probably mathematics knowledge is not needed. However, it has been found that interdisciplinary research can effectively take place amongst all those areas. Now, this applied mathematics, though I said I do not agree to it, so I'll be saying that this is what we call as applied mathematics is the mathematics actually which has direct implication on certain areas. So when we talk about applied mathematics, if some result is proved or some result is implemented that actually inspires other mathematicians to make use of different mathematical results and discoveries. But a mathematician actually, superficially, if someone is asked what kind of vast activity the mathematicians around the world are doing, it is very easy to come up that mathematics is not at all important. That's what many people think, and it is very painful that nowadays in higher secondary class 10 or class 9 and 10 actually, there are two kinds of mathematics in CBSE. One is basic mathematics and one is regular mathematics. That means actually we are depriving a section of students to learn mathematics properly. So there have been many theorems proved. Many theorems actually have come up as conjectures, okay? But if we look at the number, and most of the works that people have been doing in the last few years are on Fermat's last theorem, actually then it will be a very small number. If we ask a mathematician that the kind of research he or she is doing, whether it has any practical application, he or she will not be able to directly tell, yes, it has some practical application immediately. So it is also pertinent to talk about G.H. Hardy, who was very content with the kind of mathematics he was doing. And at that point of time, he knew that probably his mathematics will not have any application anywhere, but actually he was proved incorrect, because later on the kind of mathematics that is used in computer security in areas in such as cryptography, the number theory is very important. That means he did some mathematics without looking at what may be the applications, what may be its applications in future. He was obsessed with the beauty, like we are obsessed with the beauty of the nature. He was obsessed with the beauty of the mathematics that he was doing. But unfortunate that he could not see that how extensively his mathematics has been used in present time. Now, there are certain areas of mathematics which people say that it falls under applied mathematics. There are certain areas only I am mentioning. It is not limited to those areas only. There is something called graph theory, differential equations, which I deal with more or less every day. Numerical analysis, which I need to substantiate my results. Fluid dynamics, I pick practical problems from there. And there is a big area which is developing actually, which is a very good mixture of mathematics and biology called mathematical biology, where the mathematicians and biologists have come forward and they have solved actually many problems which were not possible when a biologist was working in isolation or a mathematician was working in isolation. So I'd like to just quote one example. So I had a senior friend who was working as a professor in the Center for Atmospheric Sciences in IIT Delhi, Professor Girija Jairaman. She has retired long time back. So when I visited her center, she took me to the backside of her department, I mean the center. Then I saw there is a small pond. I said, what you are doing? She said that I have some fish here, and you can see those things that I have kept there for the fish to eat. I said, what you are doing? She said, I'm just doing the mathematical modeling, the how the fish grow, what is the longevity if the fish actually eat this kind of nutrients. I said, how all you are doing? She said, no, I'm actually working with a person who has a PhD in zoology. So that clearly shows the interactions, a successful interaction of mathematicians with other areas. Then we know theoretical computer science is nothing but actually it is mathematics. So most of the people who work in theoretical computer science, whether they are working in the department of mathematics or they are working in the department of computer science, they actually utilize plenty of mathematics. Then there are many problems actually which needs an optimized solution. And actually this is in high demand nowadays, which is also related to what we call as financial mathematics, which deals with shares, debentures, and all those things. So these are the areas actually people, if you see superficially, these are the areas we'll say of practical importance. But I'd like to add that each and every area of mathematics is important, whether it has an immediate application or not, because in 50 years or in 100 years, we may be using some result of mathematics which may seem very abstract or impractical at this stage. And due to necessity, actually, research in all those above mentioned areas has been increasing at a very fast pace, and actually it is having a direct impact or sometimes maybe indirect impact on society. And as I said, my definition of society is very broad. It includes each and everyone in the whole world. Now, when we want to produce some result, the first question comes, how this result is going to help the society. Now, when we talk about mathematics, when we talk about mathematical research, even there are many people who have university degrees, but not in mathematics, sometimes ask me, you have a PhD in mathematics, you say you do research in mathematics. What kind of mathematics research you can do? We almost know everything. Then it becomes a very hard time for me to convince what kind of mathematics people do and how it is actually contributing to the academia and research and also to the society at the same time. But it is not very easy to realize, or it is very difficult to visualize the contribution of mathematical research on day-to-day life. There will be some theoretical results, but we cannot claim immediately that what explicit contribution it may have to our day-to-day life. But we may be able to at least argue that these will form foundation for solving many practical problems, if not all. And from my side, I like to say that if we deeply look at the kind of research that is going in mathematics, every area of mathematics, whether we term them as abstract or as applied, it contributes immensely to the overall growth of mathematics and hence to many applications actually which are carried out in different areas. So now I have put it on record actually, what is society for mathematics and mathematicians? Society has a broad meaning. It is simply not something which provides short-term solutions. We see the world as a society and the mathematics contributes to the society in a much bigger sense and over a longer period. Now, how mathematics appears in nature? You talk about planets, you talk about meteors, or any body actually which is in the universe. You talk about the movement of clouds, you talk about the rainbows, you talk about the hurricanes, tsunamis. You look at the ponds, you look at the lakes, you look at the rivers, you look at the ocean. Now it is up to us whether we can see mathematics there. It is up to us whether we see some physics there. It is up to us in some other related events whether we can see biology in it. You throw a stone into a pond, then you can see some circular waves getting created. What is the mathematics? Where does the wave vanish? And as we can see, centuries back, people were actually working with whatever was available in nature. So you come outside, daytime you will see the sun. You come outside in the evening or at night, you will see stars, you will see the moon and various other bodies in the sky. So it is how that inquisitiveness actually increased in the minds of many people, and actually people started working on it. And this is, I think, the first instance probably how mathematics actually started as an area of research. We want to know atmosphere, as I said, we want to know the cloud, we want to know about the prediction of the weather, okay? So we need to know physics as well as mathematics. Now I'm just giving you a small example, okay, in astronomy. So you can consider some gaseous star. We know that when we are talking about gaseous star, the mass will not be constant all the time. The mass will be changing. So it will have some variable mass. So you take a radius and you assume that the mass lies in that region. Okay. Now you will have many unknowns there. You will have the unknown mainly as the mass, which will be related to the density. Okay. You know that whenever we have some mathematical problem with differential equation, they will be accompanied by boundary conditions or initial conditions in case of ordinary differential equations. And we may have both boundary conditions and initial conditions when you are talking about solving some personal differential equation. So what are the conditions we will be given? We will have two boundaries. One boundary will be the center and another boundary will be the surface of the planet or the star. Okay, so by solving these problems, whatever conditions are given, actually we will be able to find the mass of the star. Now we know about satellites. Okay, we know about the moons. So our Earth itself has one moon, and various other planets actually have various numbers of moons. Okay, so now there is a system of equations which actually defines the orbit of a satellite of a planet. So you can see that we are considering in three-dimensional context. So you consider x, y, z as the Cartesian coordinate system, then actually you will come up with three differential equations, which after solving that actually you will be able to talk about how the star is moving along its orbit. Okay, so where r is the distance between the planet and the satellite, which will be variable because we know that it is moving in an elliptic orbit. So having said that there is a huge contribution in astronomy of mathematical research. So nowadays also, as I said, the mathematical biology is developed as a subject where actually the mathematicians and biologists work together. So I think Dr. Talukdar will be interested in this area of mathematics. So now I think previous speaker talked about some drugs. So it is about production of drugs. But now when a drug is produced, whether you want to inject it or you want to take it as a tablet. So drug delivery is a very important issue. That means you always want to find that whenever a drug is delivered into a human body, people get free from their illness. So there are many mathematical models actually which actually states clearly about the intensity, about the way actually the drug flows through the veins and goes to the area where actually the body needs recovery. Then we talk about cancerous tumors. We talk about any other disease. we talk about the growth of cancerous tumors. Then we want to retard it. We want that a person should get actually should recover from his disease. Then we have to know how the cells are growing. At the same time, what should be the best possible method to retard or actually diminish the number of actually affected cells so that the person gets actually cured. Okay. Then now this COVID-19, so I was not thinking of putting this line here, but I thought since COVID-19 is the actually hot word in for the last 3-4 months, actually there are many epidemic models. Actually now, since COVID-19 is a very recent phenomenon, so epidemics, like we talk about cholera and all those things, there are very well established mathematical models actually. And I'm sure actually those mathematical models have been studied extensively to actually eradicate those kind of epidemics altogether from many countries, including India. And let me just say a few sentences about COVID-19. Being a mathematician, I have actually come across a number of publications actually which actually involve mathematical formulation for COVID-19, how the virus is moving and all those things. And I have also studied some papers which are statistical in nature, which actually probably is in a position to predict what kind of intensity the disease or the virus will have after a few months. I'm happy to say that one of my colleagues, Dr. Palash Ghosh, who is a statistician, he has actually developed one model in collaboration with the School of Medicine of National University of Singapore, NUS, where he has collected data from all the states of India, the number of affected people. Then he has two models. One is semi-linear model and another one is exponential model. And it can predict actually after 1 month what will be the number of affected people in the whole country, and if you want to talk about whole in a state. But there are certain constraints on the model, in the sense that now all of us realize that the number of COVID-19 affected people was very small about 1 month back, I think May 25th, when the flights started coming, Shramik specials started coming. Now it is very difficult for this model to take into account how many people are likely to come back to Assam in the next 1 month, say from Kerala, from Karnataka, from Maharashtra, from Delhi, or from Rajasthan. But they have made some projection, and as I see the model, actually the prediction seems to be quite okay at this stage. I have come across certain mathematical models. There have been some publications, but I think they are actually hurriedly submitted and hurriedly published papers by some of the journals, because it is a very hot topic. And unless actually these models are actually compared with some experimental data, it will be very difficult for us to believe that those mathematical models that have been developed for COVID-19 are accurate. It is not a criticism, it is just my apprehension that, because many times what happens, actually, if you remember few years back, there are a lot of PCOs, public call office. Then every unemployed person started having a PCO. Then actually what happened? All the PCOs had to stop down. So it is actually, because the research demands that mathematicians also deal with COVID-19, many people are working on it, many people have come up with, and the journals actually, because the peer review process takes a lot of time, the editor himself probably reads and thinks, okay, the equation looks correct, let me get it published. Now, whenever I talk about modeling, so I'm talking about a modeling which is not a statistical modeling. I'm talking about a mathematical modeling which actually essentially has one governing equation which actually governs the whole process. That is a must for any model. Then we need to have some initial data, because whatever model we consider, once we solve it, it has to satisfy an initial data. Now in mathematical biology, it is a predator-prey model, which is actually very familiar with many people working, and actually there are many variations of this predator prey model. Predator prey model is basically, you can see it has come from history. A tiger jumps on a deer because deer flesh is the staple food for the tiger. Now, how many tigers are there in a forest? What is the population of the deer in the forest, so that every tiger can get sufficient food for its existence? Okay. Now it has been generalized. You can talk about something which is being attacked. There is a disease which is attacking people. So you want to know everything about the disease, and at the same time you also want to know the population. You also want to know about lot of constraints. So there are some new constraints, like I do not know if the mathematical biology earlier thinks that there is some kind of epidemic in an area, whether quarantine that is being followed now was strictly followed. Because we know if quarantine facility is available and it is strictly followed, the number of actually affected persons will go down. And actually, if the quarantine system is not followed by people, then actually the number of persons will, affected persons will increase. So there are many constraints. There are many things that the human, they have to control. Okay. This is a general model actually. So it is in two variables, X and Y, which actually depend on T, but it is kind of some autonomous system where if you see on the right side, left side, we have some derivatives of X and Y with respect to T. That is the variation of X and Y with respect to T. But if you look at the right hand side, the variable T is absent. So these are equivalent to something called autonomous system, and there are certain mathematical constraints, and it is expected that the model that we are considering, the problem that we are considering actually follow this constraint. Then we can come up with a solution which can tell us actually the kind of population that may get affected from a disease and so on. So this is known as the Kolmogorev's predator prey model, and it has been actually improvised, and actually many such models are available nowadays. Now, financial mathematics. Financial mathematics is something, it is not about counting how much money I have, or how much deposit I have in my bank, or how much I have to give to the shopkeeper when I buy 5 kgs of rice or 2 kgs of dal, or how much money I have to give to the Ola driver when I come from the airport to the IIT campus. It is much more than that. Financial mathematics is a very hot topic nowadays. Actually, now in many mathematics departments all across the globe, they are specializing in what is called financial mathematics. And in case you do not know, IIT Guwahati offers a bachelor's degree in mathematics and computing with mathematics department as the host, where actually in addition to mathematics and computer science, financial mathematics is also considered to be a very important component. Now we know means we hear. We talk about inflation. We know about market crash. We know about shares, right? We know that sometimes the market crashes. So what does it mean? Actually, for a layman like me or you, it is very difficult for us to understand the nitty-gritties of what is happening inside. So there are many operations of financial markets actually which heavily depend on mathematics. And when I say mathematics here, I am also actually including statistics, because when I start a company, I want to issue shares, debentures, and also I would like to know what will be the state of affairs in my company after 5 years. I cannot simply start something without having studied all those aspects properly so that I make some profits. So there are many things called portfolio analysis, nonlinear analysis, stochastic analysis, okay? So which actually hugely affect banking, investment, bonds, funds, and all other financial instruments. So now most of the financial institutions, whether you talk about bank or insurance companies, They actually have one research and development section where they would like to employ people having knowledge in mainly in mathematics, then only in some ideas in economics. So financial mathematics actually helps. It may not help a layman directly, but it helps actually many people who are working in corporate sector. This is one of the most important equations that is used, developed by Black and Scholes, which is called Black-Scholes equation, which actually talks about the fixing of price of a European model or an American option. Actually, this is also beyond my understanding because I do not work in financial mathematics, but those of my friends who work in financial mathematics, I know most of the times they talk about their modeling being modeled on the basis of Black-Scholes equation. So it actually contributes a lot, not only to the economy of a country, but it is also to the economy globally. Now there are many issues in rivers, okay, especially in a country like India, where the farmers actually depend on a regular supply of water for their cultivation. Now, being in Assam, we know the fury of Brahmaputra and its tributaries during monsoon. We have already seen a number of floods. How the flood takes place means how the river overflows, what is the flow ditches, what is the contribution of the tributaries into the river for the occurrence of flood, how much rain is happening in Bhutan, or how much rain is actually taking place in Meghalaya. That also affects the flood situation in Assam. How the sediment is taking place on the riverbed, how erosion is taking place along the river banks. If you see during flood times, if you see the news channels, you will see very painful pictures of river banks getting eroded, people losing their beloved houses and properties. And once the sediment gets deposited, how it gets transported, or if it is not getting transported, what is happening to the river bed? Is not it becoming shallow? Is not the capacity of the river to hold water decreasing? So these are mainly civil engineering problems, but there are two ways to look at those problems. One is you can have some statistical model by collecting certain data, and there may be certain other aspects like mathematical model, which may be useful in tackling floods. So right now, this is one of my new area which I have stepped in. So I am doing the mathematical modeling along with my research scholar, but it's very difficult actually. But I have not given up. I am still working, and I am going for an analytical solution first. Then we'd like to compare the results with experiment. And being in Assam, where Brahmaputra actually is the lifeline of the state, and also I stay very near to the river, it is pertinent for me also probably contribute something to the river mechanics problems. Okay, so it has many areas actually where research is going on. So red ones actually I have. So first two ones actually you need mainly knowledge of geology, not much of mathematics. But if you want to, you look at those red ones. So these problems actually cannot be solved without help of basic mathematics. So this is a basic model which is called Saint-Venant equation. Actually, it is a pair of first order partial differential equations. And of course, the kind of conditions that you will have some initial conditions and boundary conditions, will depend on what type of flow we are considering, what type of river we are considering, what type of ditches we are expecting from the tributaries into the river. So this is a basic model for river mechanics, which actually can tackle flood roads dam break flow, and many other related issues connected to river flow. Okay, so this will be a very helpful result, and that will help actually a society. So now one constraint that always exists in mathematical modeling, if you look at these two pictures, left hand side picture wise very beautiful. There is a flow, but which is actually a turbulent flow. You look at the right side, we are not very concerned about the right hand picture, because it's very unlikely that the water that is flowing through that river is going to cause any immediate problem to us. But mathematical problem, there are two kinds of problem. One is your linear problem, another is non-linear problem. So left river, if you look at, you have to deal with some non-linearity. But if you look at the right side river, you only look at the linear problem, and it will be easier for you to solve a linear problem. Being a mathematician, many times we try to reduce a non-linear problem to a linear problem, but keeping in intact all the physical assumptions that actually, without which actually the solution will be very much flawed. Actually, my main area of research, I will not say my main area, my number area, one area of research is ocean engineering, which I developed when I was doing my PhD in Canada. The selection of my thesis topic was accidental. When I joined my university, supervisor did not tell what topic I should work, but he said, you just walk around the city. So every evening I used to go to the waterfront of Halifax city. Dr. Narayan Talukdar's younger brother was with me at that time in Halifax. So then I observed the ships, I observed the waves. Then fortunately my supervisor also worked in water waves, and that's how actually I came to the field of water waves. Let me go quickly now. Again, you look at those waves. As a tourist, if I go to a sea beach, I'll be fascinated by the left picture. But when I go to a beach, as a mathematician, I would not like to see a wave like the left one. I'll be content with a wave which I see on the right side, because that is very likely to become a linear problem compared to the other one. Look at some structures, okay? So there are some oil rig. So these are called platforms that are actually installed in sea, and it is a similar type of structure you can also see in actually Bombay High in many areas near Mexico, and also in the North Sea near UK. So there a lot of mathematics is involved in that construction and installation and the stability of the structure, because the kind of wave that is going to hit the structure, the kind of forces that is going to hit the structure, unless they are evaluated properly, it cannot be a structure which is stable. Side B, it is called a okay. So they want to have some study in the ocean, so they do not want to have a on airport only in the mainland. So they will actually have some kind of floating airports in the sea. You look at the right hand side, it's a buoy actually. So there are some structures actually which are used, as all of us will agree that ocean waves actually the energy is not fully utilized. So in this age of non-conventional energy, actually there is a huge prospect of ocean waves being captured and to convert it to electrical energy. So these kind of structures are used. And also when a ship moves, a lot of mathematics is involved there, because in addition to the natural propagation of the wave, the sea also creates another wave, which is called radiated wave. So all those things are taken into account considering the structure. Then this is more of an environmental problem than a mathematical problem. But a lot of mathematicians nowadays are also taking a problem which actually deals with the very serious issue of oil spill and also dumping of garbage in the midst of the ocean, and some mathematical models are being developed. As I said, there are two theories, so I don't want to go to the mathematics part too much. So I'll just show you some structures. And so there can be two kinds of structures. One is a rigid structure and one is a porous structure. We know that when we consider a rigid structure, water cannot flow through it. But if we have a porous structure, when the water wave hits the structure, a portion of it will go through it and another portion will get reflected. So there are some pictures here. I had already shown one. This is a floating airport near Tokyo. Then there is a port in Bilbao in Spain. And the bottom two pictures are very commonly available in most of the harbors. So what it did, actually two things happen here. When a wave comes with a very high velocity, if it hits any structure like a floating airport or a port or the beach, actually, huge erosion will take place and there will be detrimental effect to that area. So what is being done, actually some porous structures, maybe in terms of rock or maybe in terms of sand or whatever, are actually erected some distance away from the seashore, so that when the wave actually hits that, and after that when it actually gets transmitted and hits the shoreline or the port or the bay, actually the speed is very much reduced and actually impact will be very low. And the second aspect is that when it hits the porous structure, an amount of wave gets reflected, from which actually reflected energy can be tapped. Now, actually, we have one work. I have published recently a few works. One of them is this, which is actually done with one of my present research scholars, Abhijit Sarkar. I think he's logged in. So in the slide title, I showed some structures of windmill. So why windmills have gone into the ocean? So European countries, many countries are very small, so they have actually scarcity of land, but they also need windmill to generate electrical power. So what they have now done, they have actually gone into the ocean and they have installed certain structures so that the wind energy that is generated by the windmills installed in the ocean can be converted into electrical energy. Then while those structures are already in place, another class of people thought that since one structure is already there, why can't we have some kind of ponds in the ocean where actually we can carry out pisciculture? So that is what the sea cays are. Sea cays will be around the structure which is installed for the windmill, and actually they can actually breed various fish species and also certain seaweeds. Okay, so this has come now. South Korea, Spain, and many other countries actually are experimenting with it, and some of them say that they have already obtained good results. So this is how the structure will look like. The outside structure I am showing on the right side, and actually the whole structure I am showing on the left side. So there will be the windmill structure, then which will be surrounded by another structure where agricultural pisciculture will be developed. Now, what is the benefit? Now, one thing is definitely benefit we can see is that from one structure, actually, we are getting two benefits. We are getting wind energy and we are also actually cultivating aquaculture. That means we are actually reducing the cost, because having some kind of installment in the ocean is very expensive. So a lot of money can be saved. Not only that, actually environment in ocean is also very important. Now, instead of having two separate structures, actually we are having one structure and we are having actually multiple use of it. And there is a lot of cost savings actually. Cost saving, what it means to the country, it also means to the taxpayer. If cost is less for a country, then as a taxpayer, actually I'll be paying less. But if cost is more, as the country is suffering, then as a taxpayer, actually I'm going to pay more tax. So these are certain things that can be developed in this kind of structure. So this is the mathematics part. So I'd like to avoid for two things. First thing is that it is too much mathematics. Second thing is that I think my time is more or less over. Okay, so this is some kind of mathematical model where we have to know about the velocity of the wave, when it hits the porous structure and how it goes inside the first structure and hits the second structure. So there are certain important aspects that are talked about, is called the velocity potential and the velocity of the structure, and also the hydrodynamic pressure that will be working on the structure. Okay, so then there are certain parameters that we have to consider when we look into the mathematical formulation. So linear theory is used, but it has been proved and it has been compared with experimental results, and those kind of mathematical models have been actually approved by scientific community. And as far as I know, many people working in ocean engineering, actually they look at those kind of mathematical models, which is going to help very intensely. So for the mathematics part, actually my cylinder will look like this. The inside cylinder is a rigid cylinder. Then the outer cover is a porous cylinder. Then in between we have water region where actually the second activity will take place. So now the work will be how the reflection takes place, how the transmission takes place, and what kind of force actually acts on it. Okay, so I think I'll skip the mathematics part. But what I would like to say is that this kind of mathematics, I'll just show you the kind of equations and the solutions that we get. Okay. So these are certain results which will depict actually what kind of porosity should be considered for the optimum benefit, what kind of depth actually should be taken into consideration, what should be the height of the structure, what should be the radius of the structure. All those ratios have to be experimented numerically and come up with certain structures actually, which is going to benefit the community who are dealing with this kind of work. As I said in the beginning itself, I cannot claim that the kind of contribution that mathematics makes, or the kind of contribution that the mathematics I am doing is going to help the immediate neighborhood. It is not always true. But if it helps a community, a scientific community, an engineering community, or a designing community, that means it is fruitful. So in that case, actually, I can say that this is a contribution to the society, and society as a whole. It is the global society. Okay, these are some conclusions. Okay, now I thought I'll end with, I am also a movie buff. I love movies, and most of you, whether you are a mathematician or not, you must have watched these movies. Or if you have not watched those movies, I request you to watch those movies. One is A Beautiful Mind. It is a movie on the life of John Nash, brilliant mathematician, eccentric mathematician. See what he won. He won a Nobel in economics. That establishes the fact that what is the contribution of financial mathematics to the society. And equally, he also won an Abel Prize. In case you do not know what is an Abel Prize is the equivalent to Nobel Prize in mathematics. Okay, since you know that there is no Nobel Prize in mathematics, so we consider Abel Prize to be the equivalent to Nobel Prize. Okay. It is beautifully written by Sylvia Nasser and actually very efficiently directed by Ron Howard. And the second movie we should be proud, all should be proud of. We all are proud of Srinivasa Ramanujan. If we want to talk about any Indian mathematician, we always talk about Ramanujan. You should read this book by Robert Kenizel, and also watch the movie by Matthew Brown, where Dev Patel actually has acted as Srinivasa Ramanujan. And we will be able to appreciate more, considering the constraint that Srinivasa Ramanujan faced, and considering that he died at a very early age. The amount of contribution he has made to mathematics, the enormous implication that it still has on mathematics all world over. We should be proud of Ramanujan, not just as a mathematician, but for putting India on the world mathematics map. And still, when people abroad talk about Indian mathematics, they talk about Srinivasa Ramanujan. So let me conclude. So mathematical research has both direct and indirect impact. its impact on day-to-day society may not be visible immediately. As I said, the definition of society can have different implication to each individual, but we probably need to see our contribution at global level. That means for a bigger society, whether it is abstract or it is application oriented, mathematical research has huge impact on a greater society, and it definitely serves as a backbone to research in many areas of science and engineering. So I end my talk with a quote by Carl Friedrich Gauss, one of the most celebrated mathematicians of all time. He said, mathematics is the queen of science, and out of it, arithmetic, the queen of mathematics. So he has very aptly put the contribution of mathematics to all branches of science. So when we talked about science during the time of Gauss, there was nothing called engineering. Engineering was part of science only. But I was just wondering why he did not say that mathematics is the king of science, because we always know that king is more powerful in a country, but Gauss himself actually proved that it is not true. Like at home, it is not the male member who is at the control of the helm of affairs. It is the lady, my mother or my sister or my wife, who will be controlling everything in at home. So similarly, I feel that's why actually Gauss centuries back realized that yes, mathematics cannot be the king of science, but it has to be queen of science, which is followed by the king. So these are some of the references. So I'd like to thank actually Abhijit Sarkar, my research scholar, who actually inspired me to work on that model that I showed about the windmill and pisciculture, and we have got a very good publication in an Elsevier journal. And also equally, I am thankful to all my previous research scholars, starting from Subhas Martha, who is at IIT Ropar as a faculty, Smritiranjan Mahapatra, Santu Das, Sunanda Saha, Nilam Chaudhuri, Jayanta, Hassan, all those who have completed PhD under me, and also my current research scholars, Avijit, Ayan, Kaushik, Vandita, Siva, Matap, and Silpi. I never believe in the fact that only the teachers can inspire the students. I think for me, my inspiration are the students. They are inspiring me to take up work, and I get involved. So I am always thankful to all my research scholars. And of course, I am thankful to Maitreyi. I think it is formal, so I have to say I am thankful to Dr. Maitreyi Sharma Bezbarua, who looks after the research activities in Downtown University, whom I know from a long time since I grew up in Jorhat. Maitreyi also grew up in Jorhat. Though we did not go to the same school, we are of the same batch. We did not go to the same college. We did not go to the same university, but still we are academically connected. Thank you, Maitreyi, for giving me a chance to deliver a lecture.
Thank you very much. Actually, you have to answer a few questions now. But before that, I want to tell you something. Although I'm a chemist by profession, but always I believe that mathematics is the king of science, you know. But today you're telling that no, it's not king, it's queen. But it is everything. Okay?
You should appreciate that.
Yes, yes. Mathematics can answer everything. I really believe that. And if I go for my next life, I will definitely become a mathematician. That is my wish. Okay, I'm so much love with mathematics. Okay, then your question is the chaotic system involving undefined initial conditions for coupled differential equations and artificial neural network algorithm, rheological fluid dynamics, though advanced mathematics seem to be capable of direct application like the weather forecast, can this be cited as direct impact on society?
I'll just say, without looking at the subject, anything that mathematics contributes is a contribution to the society, directly or indirectly. That's what my stance is. So like neural network and all those issues actually, and like, as you said, weather forecasting and all those things. So the way physics is important, equally mathematics is important, because I feel that physics and mathematics are actually the two sides of the same coin. Neither mathematics can exist without physics, nor physics can exist without mathematics. And whatever contribution as a whole, if we see, I think when we look at the contribution to the society, we should not look at which subjects have contributed what, but we should try to see that we can amalgamate all the contributions and we make as interdisciplinary as we can in coming to an outcome which actually will immensely benefit the society.
See, Dr. Bora, this is a question came from Shankarpadi. Just now you replied.
Yeah.
Okay.
Yes.
Now you said something is very interesting about the impact to the society and economically, because the ultimate theme of this conference is that how much research is benefiting to the society. You are one of the mathematical modeling of converting the ocean energy to the bioenergy, to the energy and to the ecosystem. How far it is now, applicable, is it undertaken from anywhere, or the technology has been transferred, it is very much feasible and economically cheaper?
I think initially, whenever you start something, it will not be economically cheaper. So most of the works are at experimental stage. But whatever outcome has come out actually has encouraged the people that then they are sure that they can go ahead with this kind of model actually for a large number, and which is going to benefit not only in terms of money, but in terms of also ecology and all those issues. As I said, like having windmills in the ocean actually saves a lot of space in the land.
Yes.
But at the same time, also mathematicians and all other people are also equally concerned that the ecology of the marine environment is kept intact.
Why don't you try with just a windmill in the Guwahati IIT campus? It's a huge area. I experienced very good wind. Did you make any attempt at the very preliminary stage?
No, that is, I think, one shortcoming on my part. So I am so much enthusiastic with my own mathematics.
Yes.
Actually, I should come up with certain practical experiments.
Right.
Okay. So that it is helpful, but I think it will be very costly. But I hope if I write a very good project, then I may be able to get money from some funding agency. And it is very likely that we'll be able to. I had some actually earlier project with civil engineering department where we had discussed about well and the aquifer, and we are talking about the porosity of the soil and how water comes and how water gets polluted and all those things. So some kind of work, experimental work also we have done.
Yeah, and I really appreciate the way you have your mathematical modeling to the practical and the designing of the equipments and other things. It's really amazing, and it's really fit to the theme of the conference. Once more, thank you very much, Bora.
Thank you so much. Thank you.
Thank you very much again.
No more questions, huh?
No more questions. Yeah, that was the only question.
No, can I ask something?
Narendra,
yes,
Sarup, it was an excellent talk. I really enjoyed it. I see. I am at a fag end of my career. You are also becoming matured. Like this. What can we do? Have you given a thought that maths as a subject of inducing fear in kids when they are in the elementary level, which has really caused it's science to grow in this part of the country.
Actually, yes.
I think there is no second opinion. Without mathematics, nothing can move. No?
I can elaborate on it. Basically, since the topic was about mathematical research, I did not mention about that. But I am equally curious. I tell my friends actually what research I am doing is probably not going to help a big percentage of people. But actually, there are many initiatives that we have been taking. Okay. Now, actually, there is one program called Mathematics Training and Talent Church program held all over India since 1993. And we have been hosting it for a number of years. This time it has gone online, where actually we want to motivate students to come up with ideas of mathematics and how actually mathematics is to be tackled easily by understanding it clearly. That is first issue. It is for good students, not for all students. Your question is something else. It is for those students actually who are really interested in mathematics. But your question actually goes to another section. Your question is that how that fear, but I do not know actually how the fear has come. I think we are to be blamed. If some student or a child of mine does not like mathematics, so first of all, we probably do not know how to help. Second thing, we may take it very lightly, may say, oh, yes, I was also scared of mathematics when I was a kid, right? So what I understand and would like to follow is that mathematics teaching is very different from any other subjects that you'll agree, right?
Yeah.
So though you have a very good, strong background in biological sciences, but you have been, I'm sure you have been a very good student and you are good in all subjects, right? Now the problem arises is that I feel, first, that is my opinion. I cannot generalize, it's a global opinion. When we start teaching mathematics to students, we do not adopt a very proper method. Recently, means last year, I had gone to Finland, and you may be knowing Finland has the best school education. The students spend less amount of time inside the classroom,
Yes.
but they spend most of the time outside.
Yes.
But our knowledge is always bookish.
Just worse.
We are inside the room, we look at the board, what the teacher writes, and we just want to memorize, right? But as I said, how mathematics evolve, nature, you go out, you try to see what is happening, whether you have mathematics in the trees, whether you can see mathematics when Narayan Talukdar is walking, when you can see mathematics when Dr. Unni is looking at the computer screen. So I think we have failed as a society to imbibe in the student the practically how mathematics looks like.
Yes.
It is not simply some theorems, some formulas.
Yeah. I
We
agree.
have to connect it to nature. We have to connect it to practical.
Exactly.
So I think the education that we are following means we also were students. I frankly telling there are many things that I learned in school and college. Later on, actually, when I became mature, I have started understanding, oh, the way I remembered, I just remembered. I
Yes,
didn't
absolutely.
understand.
Very correct. Yeah.
And what we should do, we have to imbibe in the students or our own children to think. I always tell my research scholars, they will agree. Or some established mathematician, he has said this is the equation. I said this is the equation, but how do we know how it has come? You try to explore what each term means. Whether this equation can also appear in somewhere else. Why those boundary conditions come? Unless you have to be practical, you have to try to understand either through geometry or through nature or through physical. So I think we are lacking behind and we have failed. Though we may say there are a lot of good books, but if you see all good books are similar thing, how many figures you see in the books? You see some graphs. Graphs are not figures. That's what today what I told Moitri yesterday, because my mathematics I do not want to present. I will just show some structures. Now that structures, those structures are mathematics. That should be interesting. So that's what I think we should do from skill. So what we saw when we are trying to train students, first we thought mathematics has its shortcoming at bachelor's level. Then we found no, it has shortcoming at higher secondary level.
Yes.
We went down. Then we found it is at high school level. Then we went down and down. We found that we have to actually reformulate our teaching from class 4.
Yes,
Up
absolutely.
to class 3, it is more or less fine. Because up to class
Very,
3,
very well
you
said.
only need to know the numbers and some operation and all those things. But beyond after that, what happens? How do I know what mathematics I am doing? I mean, actually what is happening, it has to be made interesting.
Yes, very
That's what
true.
I'm saying. Like I talked about those 2 movies. I have read both the novels. But I feel that when I see the movie, I appreciate more about John Nash. I appreciate more about Ramanujan because I can see what is happening.
I can
So we
visualize.
have to make mathematics look, it is happening. It should not be only on paper with pencil and pen on a table. We have to go outside our room. We have to see mathematics outside. We have to enjoy mathematics outside.
If I can make a comment, if you have time, like I think very well said. And Finland you mentioned, I think Finland, the elementary school teachers, they paid maximum amount of money, maybe more than university.
That is
So
also true.
that's important thing. I just want to make a comment for all the viewers. Maybe they might find it interesting. Dr. Richard Feynman was asked towards the latter part of his career why he was so good in mathematics, and mathematics, physics, like it's all his. So he said that when he was kid, he remembered one incident that when his father was telling it about like he saw a picture, elephant in picture. In reality, how big an elephant is, his father told him that an elephant is as big as the height of their building, the first story. And then next he asked, then how big will be the ear of the elephant if the elephant is so big? He said the ear is as big as the ventilator of that building. So like then he recalled that this is what in mathematics, like he has seen mathematics in that sense.
Yes.
Since the size of the ear of an elephant is equal to the size of the ventilator, and the elephant is as tall as their building. So I think in childhood, what he said, I think all from the childhood, students have to be made more close to nature.
Yes.
And in quantifiable term, make things to learn in quantifiable term, which you don't do. And I think that is one way of generating interest in mathematics from childhood. They will not get frightened by when you compare things like that, right? You will not know the size of the window, but
what we are also doing, but we have to do it at a large level. So now reaching all the students is difficult.
Yeah.
So you may know or may not know what we have been doing last few years. We are trying to train school students, school teachers.
Very good.
Now it gets multiplied because now I cannot go to actually we have one faculty, Professor Bhavakumar Horma. He has devoted most of his time in actually mathematics education. Now it is not possible for every mathematician go to each nook and corner. So now our plan is that we'll train a large number of school teachers. We'll train. Now my society is narrow. Now I'm talking about Assam, not global society. Okay. Now we have had already 4 actually such kind of training camps for teachers in mathematics of class 9, 10, 11, 12 of government schools, because it was in collaboration with Sarva Shiksha Abhiyan. Okay. Then we are also training many times teachers of, I will not say training, we are having interaction session with the teachers teaching in college actually. So that what happens now, suppose you assume that Saurabh Nandan Bora knows something. So now I am giving it to 50%. Those 50 are going to 50 different places and they are contributing. That is the only possibility if we want to see that students don't get scared of mathematics at all.
Very good. Very good.
Okay, now the time is over. It's very interesting talk. We want to hear from you, then Talukdar sir, then Mimi sir, longer time. But always we have to end somewhere. Thank you very much again, Saurabh, for an interesting talk. And also the participants, thank you very much. I am sure that all of you are benefited by this beautiful lecture. Thank you very much.
Dr. Saurabh, come one day to university, give the same talk to the students, because it will be very good for the students to attract mathematics. I really appreciate it. It's a wonderful talk. Visit university, they will arrange and have a talk. Your talk is more interesting to take the student to take mathematics instead of going away from mathematics. Thank you.
Considering you and Narayan Da, you people are so much experienced and illustrated, I feel myself privileged to be in your company, and I feel really proud that you people attended and you have appreciated. So that is an achievement for me.
Yes. No, it's a very good. It's,
actually,
and you are a very good philosopher also. That is the way, when Dr. Talukdar has mentioned that, the way you replied, a mathematician always would be a very good philosopher. That's the reason, I always go with NC Talukdar. He has also got the same philosophical mind. Good. Thank you.
Okay. Tomorrow will be our last session, last day of the webinar lecture series. And tomorrow's speaker will be, first speaker will be Dr. N.C. Talukdar, and the second speaker will be Dr. B.G. Unnisar. And I request all the participants to join the webinar lecture series. Swarup, you please also kindly join.
Sure, I'll try
Possible,
my
okay?
best.
Okay,
Thank you.
and that will be followed by valedictory session. Okay, thank you very much. Thank you very much,
Thank
all
you.
the participants. Thank you.